All right. This is the answer guide for exercise set 1.1 for AP Calculus. So, first problem, we are given a piecewise function g of x. We're told that it equals 2 from 0 to 3, 3 from 3 to 5, and 7 from 5 to 8. And the first question is to sketch a graph. In sketching a graph, you can use the 10 URL, which will help you out. If you didn't do that, I'm gonna go ahead and sketch it on here. So I only need, if I look at my x values, I only need from 0 to 8. So I'm just gonna mark them here. We have 0 over here, we've got 8 over here. And then I'm also gonna mark my boundaries. So I have 0 to 3, I'll put a 3 here. And I have 3 to 5, I'll put a 5 here. And then I have 5 to 8, so I'm good. So I'll also mark here my values. So we're gonna have 2, I'm gonna count it by 1. 1, 2, 3, 4, 5, 6, 7. Put the top there. And let's plot. So it's equals 2 from 0 to 3. So when x is 0 to x is 3, our value is 2. So we're just going to draw a straight line from 2 to 3. Okay? And then from 3 to 5, x equals 3. Or our function equals 3. So we're going to draw a straight. Okay, actually, important to note here that it's not greater than or equal to 3. It's just greater than 3. Meaning that at 3, we're actually going to put a open circle there because we're not including it. That greater than sign means we're not including it. But we are including 5. It is closed at 5. Okay. So we're going to close hole there at 5. We're equaling 3 from 3 to 5. And then lastly, we're going to equal 7 from 5 to 8. Again, open hole because it's just a greater than 5. We're going to be up here at 7. Open hole at 5. All the way to 8. Closed hole because it's equal to. And then we have, so this is our function. Is this function continuous? No. No, it is not continuous because of these gaps, right? If we think about the lifting the pen off the paper analogy, right? When we go through each of these parts of the function, I have to lift up my pen twice in order to finish the function. So it's not continuous. There are gaps in function. Okay. All right. B. Shade the area between g of x and the x-axis. Find the area which you shaded underneath. Okay. So I'm going to shade these regions. We're just going to make a series of rectangles and then find the area of them. So the area from 0 to 3, this is, remember, area of a rectangle is based on type. So this is 3 by 2. So this right here is 2. 2 times 3 is 6. Here we have 3 to 5, that's 2 by 3. From here to here, that's 3. So here, 3 by 2 is 6. 2 by 3, that's also 6. And then here we have 5 to 8, that's 3 by 7. So we're going 0 to 7. So from here up to here, it's going to be 7. 3 by 7, I can put it up here too, is going to be 21. This is not exactly to scale my graph, but this roughly looks like this. And now we're just going to add these all up. 6 plus 6 is 12, plus the 21, that is 33. So A area equals 33 units squared. Okay. G of x is an example of a step function. Why do you think it's called step function? Well, visually looking at it, I mean, for me, it looks like a set of stairs. It's a series of flat lines, right? like a set of stairs. Okay. 21. Given the following functions, compute the given values. So f of x, we have a piecewise function. It's 4 minus 3x for everything less than or equal to 1, and it's x squared for everything greater than 1. So we need to find f of 0, f of 1, and f of 3 off the side here. So f of 0 first. Okay, so 0. Again, you're going to look at your piecewise function. 0 is less than 1. So I'm going to use this equation, this part of the function. F of 0 equals 4 minus 3 times 0. 3 times 0 is 0, so this just equals 4. Okay? F of 1. Okay, which interval is that going to be on? Well, this is greater than 1. Not including 1, only greater than 1. This is less than or equal to 1. This is the one I want to use. We're equal to 1, so I'm going to use this. F of 1 equals 4 minus 3 times 1, that is 1. Because 3 times 1 is 3, 4 minus 3 is 1. Last one, f of 3, that is greater than 1, so I'm going to be using my second part, equals 3 squared. That's 3 times 3, which is 9. Okay? Next one, similar. F of 1. So for less than 3, I'm square root of x. 1 is less than 3. So this is going to be the square root of 1, which is 1. F of 3. 3 is not less than 3. 3 is equal to 3. So I'm going to use my second one because this is equal to or greater than 3. That is 3 minus 3, which is 0. Last one, f of 9.4, that is greater than 3. So I'll be using the second equation. That is 3 minus 9.4, which is going to be negative 6.4. Okay, backside. Again, similar situation. This time we have 3 different functions, or 3 different parts to our function, over 3 different intervals. First, f of negative 3. First step, where is negative 3? Well, negative 3 is less than or equal to 0, so we're going to be using negative x, so it's going to be negative 3, which is 3. F of 0. Again, 0 is equal to 0, so I'm going to be using this interval. Negative 0 is just 0. Last one. 2 more. F of 0.5. That is between 0 and 1. That is between 0 and 1. So I will be using this equation, 5 over x. That means 5 over 0.5, which is 10. Okay? 5 divided by half is the same as 5 times 2, which is 10. Last one, f of 4. That over here. F of 4 greater than 1. I'm going to be using that equation. Equals 6 minus 2 times 4. That is the same as 6 minus 8, which is negative 2. Okay? All right. Now it says sketch a graph of f of x from part C. So I want to graph this. Well, I am going to just draw a rough axis here. And again, I'm going to take some notes of where my intervals are. So I have 0 here. That's one main interval. And then 1. Move 1 over here so I have some space. We have 0 and 1. And this needs to be a rough sketch. It doesn't have to be exact. So negative x from, which is less than or equal to 0, means that I'm just going to have a straight line coming out of here with a slope of negative 1. Right, so this is my first part, negative x, up until 0, and this is a closed circle here at 0. Then greater than 0 to 1 is going to be 5 over x. So that's going to be, well, it's not actually going to be a closed circle here because 5 over 0, that does not exist, right? You can't divide by 0. So the next thing you're going to get when you divide by like basically 0.00001, you're going to get a massive number. So what you're going to get here is what's called an asymptote, which we'll be talking about soon. It's going to be going straight up here. and getting smaller until we get to 1, where we should be at 5, right? Because 5 divided by 1 is 5. And then for greater than 1, 6 minus 2x. Well, when I put in 1 to that equation, I get a 4. So I'm going to do an open circle just below here. That's going to be 4. And minus 2x. So it's going to be a steeper descent down, something like this. And that is a rough sketch. Okay? All right. Last question. In order to mail a letter in the United States, postage must be paid based on the weight of the letter. Although rates are tied to the number of ounces, the U.S. Post Office does not allow for payments in partial ounces. For example, if your letter weighs 6.1 ounces, you must pay for 7. The graph showing the postage rates below for letters weighing fewer than 5 ounces for the year 2009. This is an example of a step function. How much would you pay for a letter weighing 2.9 ounces? So I'm going to go ahead and just make this easier by labeling my x-axis. When I'm looking for 2.9 ounces, I'm just go here, 2.9. It's going to be straight up. It is under 3, so I will be paying this rate right here, which is 78 cents. So 2.9 ounces equals 0.78. Okay. 3 ounces. Now, when I hit the 3, I'm not going to go to that open hole. I'm going to go to that filled hole. And the distance between these is 17 cents. So that's going to be 95. This is 0.95 right here. For 3 ounces, let me put across to this. 3 ounces, you're going to pay 95 cents. And then for 3.1, it's still the same, right? If we go just 1 point over, we're still on this level of payment. The 3.1 is also 0.95. Okay. Last part is to write a function that represents the rates. So this can be, I'm going to write out f of x. That's my function. And then I'm going to draw out my brackets like this. And then I'm going to write down my different values. So I have 1, 2, 3, 4, 5 different levels. I'm going to start from lowest to greatest. So at we have 0.44. We have, I'm going to go by 17 cents at a time. So we have 0.44 right here, and then we're going to have 61 cents. Then we'll have 78, then we'll have 95, then we have 112. So I'm going to write those out. 0.44, 0.61, 0.78, 0.95, and then 1.12. So those are my values right here. But then I need to put my intervals. Kind of like above, you have your values on the left. Like this will be output, right? But you need to put your x values, your intervals. So my value is 0.44. Now that is from everything from, so I'll put a 4 x greater than 1, greater than 0, but less than 1. 61 cents for x, now notice the filled hole, greater than or equal to 1, but less than 2. 78 cents for x, greater than or equal to 2, but less than 3. 95 cents for x is greater than or equal to 3, but less than 4. And then 1.12 for x is greater than or equal to 4, but less than 5. And I know that it's less than or equal to or greater than or equal to based on the hole, right? So if it's a filled hole, right, like this, that's going to be greater than or equal to, right? But this right here, this is a less than because this is an open hole. Okay. So you say like less than, right? Okay. All right. That's it.